looks like we've got a pretty hefty stack of articles here all about the history of robots.
Quite a collection.
Yeah, you've really gone deep on this one. So, tracing these mechanical marvels all the way from, well, science fiction, it seems, to the reality we live in now. I mean, robots are walking among us.
It really is a fascinating journey from those early imaginings to the incredibly sophisticated machines we have today. It's amazing.
So where do we even begin with something as massive as the whole history of robots? I mean, the word itself. It's been around for over a century, hasn't it?
It has. And you know, the origin of the word is, it's actually pretty surprising. Yeah, it first popped up in 1921 in a play called RUR.
RUR. What's that stand for?
It stands for Rossum's Universal Robots.
Okay.
Written by Karel Opek. And get this, the word robot actually comes from the Czech word for forced labor.
Forced labor. So, I mean, right from the get-go, there's this idea of robots as workers, servants almost.
Absolutely. And the play itself really digs into that. It's all about these artificial workers who end up rebelling against their creators. And it's kind of crazy how this play, over 100 years old now, really set the stage for so many anxieties we still have today about robots, you know, taking over, replacing us.
Yeah, even harming us. Which is funny because we see a lot of those same themes.
Oh, absolutely.
Even in modern science fiction. And speaking of science fiction, didn't Isaac Asimov, the big science fiction author, didn't he have some thoughts on this whole robot thing?
He did. Back in 1942, he introduced his famous 3 laws of robotics in a short story. Runaround, it was called.
Oh yeah, the 3 laws. It's been a while since I've read any Asimov, though. Can you remind me what those laws are again?
Of course. So the first law says that a robot can't hurt a human being.
Okay.
Or even allow a human to come to harm through inaction.
Robots can't hurt us.
Right.
Makes sense. What about the second law?
Okay, so the second law states that a robot has to obey any order given to it by a human, unless, of course, that order would violate the first law.
So robots got to listen to us, unless it puts a human in danger. Gotcha. So what's the third law then?
Right. The third law basically says that a robot has to protect its own existence. But, again, only as long as doing so doesn't conflict with the first 2 laws.
So self-preservation, but only after human safety and obedience. It's interesting how those laws kind of create a hierarchy for robots to follow. But I'm curious, how much have Asimov's laws actually influenced real-world robotics? I mean, they were written for fiction after all.
That's a great point. And it really speaks to the power of science fiction, doesn't it?
Yeah.
How it can shape our thinking about technology. I mean, we don't have robots walking around today that are programmed with Asimov's laws specifically, but those principles, those ideas, they've had a huge impact on discussions about safety, ethics, all of that.
Right.
You know, for example, engineers working on self-driving cars. They have to wrestle with some really complicated ethical dilemmas. Like, how should a car react in a situation where avoiding a collision might put a pedestrian in danger?
It's a tough one.
It is. And it really shows how those laws, even though fictional, still have relevance.
Yeah, it's like even if they're not written in code, Asimov's laws have shaped the way we approach these things.
Absolutely.
But I'm curious, how do we go from fictional laws to, like, real, actual robots working?
Right.
I know there was a time when robots started showing up in factories, right?
Yeah, exactly. So 1961 was a big year. That's when the first industrial robot, Unimate, started working on a General Motors assembly line.
Unimate.
Uh-huh.
So that was really the moment the robots went from concept to reality.
It is a huge milestone.
So what was Unimate like? Was it just a big robotic arm like the kind you see in car factories these days?
Yeah, pretty much. It was a hydraulic-powered arm with 5 degrees of freedom.
5 degrees of freedom. What does that even mean?
It means it could move and rotate in 5 different directions.
That's pretty advanced for the time, I'd say.
It was. But programming Unimate back then, that was a whole different story. They had to physically move the arm step by step to teach it each action. It was a really hands-on process, literally.
Wow. That's so different from the programming languages and all that fancy stuff we have today.
Oh, absolutely.
It's amazing to think that those early industrial robots, they really paved the way for the automation we see now. Everywhere.
They absolutely did. And then, shortly after Unimate, along came another groundbreaking robot. Shaky. Shaky.
That's an interesting name for a robot.
Right. Well, Shaky was developed in 1966 at the Stanford Research Institute.
Okay.
And it was the world's very first intelligent mobile robot.
Intelligent mobile.
Yeah.
So It was more than just a robotic arm stuck in a factory. It could actually move around on its own.
Exactly. Shaky had cameras, it had touch sensors, and get this, it could navigate rooms, it could avoid obstacles, it could even interact with objects like doors and light switches.
That's incredible. So it was like a robot straight out of science fiction. I bet people were blown away back then.
They were, I mean, Life magazine even called Shaky the first electronic person.
Wow.
It really captured people's imaginations and showed the world what robots might be capable of.
So while Shaky was, navigating rooms and stuff, were other researchers still working on the whole robotic arm thing, trying to make them even better?
Absolutely. And that's where the Stanford arm comes in.
Oh, right. The Stanford arm. I read that it was pretty influential.
It was incredibly influential. So they developed it in 1969, and it ended up becoming the blueprint for the entire industrial robotics industry.
Wow.
And unlike Unimit, which was, hydraulic, the Stanford arm was all electric, and it was controlled by a computer.
So that was a major upgrade.
Huge upgrade.
Did the Stanford arm ever make it out of the lab?
It did. It eventually made its way from Stanford to MIT.
Oh, okay.
And there it got further developed and, commercialized.
Okay.
And it became the PMA robot. Yeah. Programmable Universal Machine for Assembly. And the PMA ended up in factories everywhere. It's amazing to think about how much it's influenced the robots we see today.
Yeah, it's incredible, from universities to factory floors all over the world.
Exactly.
So at this point, robots were still pretty much stuck on Earth, right?
Well,
When did they start reaching for the stars?
actually, it happened sooner than you might think. 1970, the Soviet Union landed Lunokhod 1 on the moon.
Hold on. A rover on the moon in 1970.
Yep. It was the first robot ever to explore another celestial body.
That's incredible. What was it like?
Picture this, a bathtub-shaped vehicle
Okay.
on 8 wheels powered by the sun.
Wow.
And they controlled it remotely from Earth using cameras and antennas to get images and data back.
So we were driving robots on the moon before we even had smartphones.
It's wild, isn't it?
That's amazing.
And Lunokhod 1 was a real pioneer. It worked for almost a year, which was way longer than they expected. It sent back all this incredible information about the moon, like data on the soil. It proved that robots could be incredible tools for exploring the unknown, even in the harshness of space.
That's amazing.
It is.
But while all that was happening on the moon, back on Earth, there was this roboticist, Rodney Brooks. And he was really starting to rethink the whole idea of robot intelligence.
Oh, absolutely. Rodney Brooks was a visionary.
So what was he doing that was so revolutionary?
Well, he was challenging the traditional way of thinking about robot intelligence.
Which was?
Well, the old approach was to try to build robot intelligence from the top down.
Okay.
With, complex programming and reasoning.
Yeah.
But Brooks, he took inspiration from nature. He believed that even simple behaviors, when combined and layered, could create complex intelligence.
So instead of trying to build a robot brain that worked like a human brain,
Right.
you build in basic instincts and they evolve and adapt.
Exactly. It was a bottom-up approach. And it led to some incredible advancements in robotics, especially in robots that could navigate difficult environments and interact with the world more naturally.
It's fascinating how often nature provides the best solutions.
Isn't it?
And I love this idea of robots evolving their intelligence rather than us having to program it all in.
Yeah.
But tell me, were robots getting any closer to looking like us at this point?
That's a great question. And it's a question that Honda was determined to answer. In 1996, they unveiled P2,
P2.
the first humanoid robot that could walk independently on 2 legs.
Hold on. A walking robot in the 90s. I feel like I missed that part of history class.
It was a big deal.
Tell me everything.
Well, Honda had been researching human gait for years.
Yep.
They were studying how we walk, how we balance, all of that.
Yeah.
And P2 was like the culmination of all that work.
So it really was a turning point in humanoid robotics. I mean, showing that we could build machines that moved like us.
Exactly. It was a huge step.
It must have been amazing to see a robot walk for the first time. So did P2 lead to anything else?
It did. P2 was kind of like the precursor to Asimov.
Asimov, right.
Yeah. Honda's iconic humanoid robot that they showed off in 2000.
Okay.
And Asimov was even more advanced. It really set a new standard for humanoid robots.
From those clunky early robots to robots that could actually walk.
It's amazing, right?
It's like science fiction was becoming reality. But were robots starting to move beyond factories and labs at this point?
They were. Around the turn of the millennium, they entered a field where precision was absolutely essential. Medicine.
Wait, robots as surgeons?
Yes. In 2000, the FDA cleared the Da Vinci surgical system.
Okay.
This was revolutionary. It allowed surgeons to do minimally invasive surgery with incredible precision.
Oh. So how does that even work? Does the robot actually do the surgery?
Well, the Da Vinci system has these 4 robotic arms that are controlled by the surgeon. The surgeon sits at a console, and the robot basically translates their movements into very precise actions inside the patient's body.
So the surgeon's still in control,
Absolutely.
but the robot just makes things, super precise.
Exactly. And the Da Vinci system's been a huge success. Millions of procedures have been done using it. But speaking of groundbreaking applications, let's talk about another area where robots are making a huge impact: transportation.
Ah, yes. The self-driving car. We talked about Lunokhod 1 on the moon, but now we're talking about robots on our own streets.
That's right.
I always thought of self-driving cars as like a futuristic dream, but they seem to be getting closer to reality all the time.
They are. And that dream started to become real in 2009 when Google launched its self-driving car project,
Google, the search engine.
the one and only. Apparently, they weren't content with just organizing information. They wanted to revolutionize transportation, too.
I guess so. So how did they start?
Well, they started testing in modified Toyota Priuses, and then in 2015, they did it, the first fully autonomous ride on public roads.
Wow. That must have been a pretty big moment.
It was a real milestone.
So, has Google launched an actual self-driving car service yet?
They have. In 2017, they launched Waymo in Phoenix, Arizona,
Okay.
a driverless taxi service. It's still early days, but it shows where things are heading.
So robots are driving us around already. In some places, at least. The future really is here. But what else has been driving the development of these super advanced robots?
Well, there was a major challenge issued in 2012, the DARPA Robotics Challenge.
DARPA, as in the Defense Advanced Research Projects Agency.
That's the one.
So what was the challenge?
The goal was to build robots that could respond to disasters.
Oh, wow.
Robots that could go into dangerous situations and help. They had to do all sorts of things: drive vehicles, open doors, climb stairs, even use tools.
Like a real-life obstacle course for robots.
Pretty much. It was designed to push the limits of what robots could do, and it led to all sorts of advancements in robotics: how they walk, how they use their hands, how they perceive the world, everything.
So from factories to space to disaster zones, robots are breaking new ground. It makes me wonder, what's next for these humanoid robots?
Well, one of the most exciting things lately has been the rise of commercially available bipedal robots.
Wait, I could just buy a robot that walks?
You can. It started in 2020 when Agility Robotics sold its Digit model to Ford.
Ford, the car company.
Yeah, they were using it in their warehouses. And after that, other companies jumped in. Tesla, Figure, 1X, they all started developing their own bipedal robot.
Wow. But these things probably don't come cheap.
Actually, that's the amazing part. The prices are dropping really fast. Earlier this year, Unitree came out with their G1 humanoid robot,
Okay.
and it costs just $16,000.
$16,000. That's less than some cars.
I know. It's incredible how quickly things are changing.
It's exciting and a little bit mind-blowing, to be honest.
It is a pretty exciting time to be following robotics.
It really is. This has been an incredible dive into the history of robots,
It has.
but it feels like the story's just getting started.
You're absolutely right. The real question is, where do we go from here?
That is the question, isn't it? What does the future hold for robots and for us?
Exactly. And I think that's something we should definitely dive into next time.
Sounds good to me.
Yeah.
Okay, so we've journeyed through this incredible history of robots,
We have.
from those early industrial arms to robots walking on the moon and even doing surgery. It's pretty amazing how far things have come.
It is remarkable, isn't it? And to think we've really only just scratched the surface.
That's what I'm really curious about. What's next? What's coming down the pipeline? What should we be keeping an eye on?
Well, one of the biggest things is AI, artificial intelligence.
Right.
The advances are happening so fast, it's really transformative.
AI, yeah. Seems like everyone's talking about AI these days. But what does it actually mean for robots? How will it change things?
It means robots are becoming much more autonomous, more capable. They can learn, adapt. They can even make decisions based on data in real time. We're not talking about robots just following pre-programmed instructions anymore.
So robots that can actually think for themselves. That sounds pretty amazing.
Yeah.
But also kind of scary, to be honest.
It's true. There are definitely concerns when machines start getting smarter.
Right.
But the potential benefits are huge. Imagine robots that can work alongside us, like seamlessly. They could understand our needs, our intentions. They could adapt to changing situations. Imagine what we could accomplish together.
So it's not about robots replacing us, but robots helping us,
Yeah,
enhancing what we can do.
exactly. And that collaboration, that's going to be essential as we figure out the future of work. But AI isn't the only big thing happening in robotics. There's also this really big thing happening in robotics. There's also this really cool area called soft robotics.
Soft robotics. What's that? That sounds kind of, I don't know, cuddly.
It kind of is. So instead of being made from metal and circuits, hard materials,
Yeah.
soft robots are made from flexible, adaptable stuff. Silicone, rubber, even fabrics.
Okay.
So they're literally softer.
So why is that good?
Well, they can interact with delicate objects, they can navigate tight spaces, much better than a rigid robot could.
I see.
Imagine a soft robotic arm that could pick a strawberry without crushing it.
Oh, right.
Or a soft robot that could squeeze through narrow pipes to do inspections.
Yeah, okay. So it's about being more gentle, more flexible.
Exactly.
Sounds like there are tons of uses for that.
Oh, yeah. Healthcare, for example.
Okay.
Huge potential there. Imagine a soft robot assisting with surgery or providing physical therapy with a gentle, adaptable touch.
From factories to operating rooms, it's incredible. It's like, what can't robots do?
It's pretty amazing what's being developed right now.
It is.
Yeah.
But we have to remember, all this amazing technology, it's not just about the tech itself. There's the whole societal side of things too, right?
Oh, absolutely. We can't ignore that.
As robots get smarter, more integrated into our lives, what does that mean for us
Yeah.
as humans?
It raises so many important questions, like how do we make sure they're used ethically? Yeah.
Responsibly?
Right.
How do we prepare people for a future where some jobs might be automated? And maybe even more importantly, how do we define this relationship between humans and machines, especially as machines become more intelligent?
Those are really big questions. It feels like we're moving into uncharted territory.
In many ways, we are. But think about it. We've done that before. Throughout history, whenever we've had big technological leaps,
Yeah.
there have been societal shifts, new challenges. The key is to be proactive, to talk about it openly, and to be willing to adapt.
So it's not about fearing the future, it's about shaping it.
Exactly.
Yeah.
We need to have those conversations about the ethics of robotics, about the guidelines we need to put in place. We need to make sure that we're using these technologies for good.
So it's not just about the scientists and the engineers, it's about everyone, right?
It is. Policymakers, ethicists, the public, we all need to be involved.
We have to be intentional about how we use these technologies. But even with all the challenges, I'm still, optimistic about the future of robotics.
Me too. I think we can build a world where humans and robots can coexist and, work together in a way that benefits everyone.
I agree. Humans are amazingly adaptable. And we've shown time and time again that we can take new technologies and make them work for us.
That's true. Okay, so we've talked about the big trends, the big questions, but let's get into the specifics. How do you see this actually playing out in different industries?
Now that's where things get really interesting, because the impact of robotics is going to be felt pretty much everywhere. Manufacturing, healthcare, transportation, you name it.
So let's start with manufacturing then.
Okay.
That's where robots got their start.
It is. But we're not just talking about those old industrial robots anymore.
Yeah, the ones that were caged off.
Exactly. Now it's all about collaborative robots.
Cobots.
Cobots. Yeah. They're designed to work right alongside humans, help with tasks that are dangerous or repetitive or really precise.
So it's all about teamwork.
It is. Humans and robots working together, each doing what they do best.
That makes a lot of sense. But what about the people who are doing those jobs now, the ones the robots are going to be doing? Are they going to be out of work?
That's a real concern, and we have to be sensitive to that. As we move toward more automation, we need to invest in education and training, help people adapt.
So it's about preparing people for the changes.
It is. We have to create a future where everyone benefits. But let's move on from manufacturing. How about healthcare? We talked about surgical robots earlier.
Right.
But what else is coming?
Yeah, what else is there?
Well, think about robotic assistants. They could help nurses with all those routine tasks, taking vital signs, giving meds, even moving patients around. That would free up nurses to do what they're trained for, providing care, connecting with patients.
That sounds like a really good thing for the nurses and the patients.
Absolutely. And it goes beyond just tasks. Robots can monitor patients, collect data. They can even alert doctors if there's a problem.
So they can help prevent problems before they even happen.
Exactly. And that's just the start. Robotics is also being used in rehab, helping people recover after injuries. And with soft robotics, we're seeing some really cool stuff happening with prosthetics.
It's incredible. It seems like robots are going to be everywhere in healthcare.
It's pretty amazing,
Mm.
and while there are definitely challenges, there's so much potential there to make things better. But let's talk about transportation now. That's another big one.
Right, the self-driving car. It feels like it's always in the news these days.
Yeah.
We're really close to seeing these things on the road everywhere.
We are getting closer all the time. There are still some hurdles, but self-driving cars are already being tested in a lot of places.
It's exciting, but I got to be honest, I'm a little nervous about sharing the road with a robot driver.
I get it. It's a big change. But think about this. Self-driving cars could actually make the roads a lot safer.
Oh, how so?
Well, human error causes most accidents.
Yeah.
And self-driving cars, they don't get tired, they don't get distracted.
That's a good point.
Mm-hmm.
And we trust computers to fly planes, so.
Exactly. And besides safety, there are other benefits too. Less traffic, less pollution. And it could make transportation easier for people who can't drive themselves.
So it's about more than just the technology. It's about the impact it could have.
It is. And that impact's going to be huge. Not just for personal cars, but for trucking, deliveries, even city planning.
It seems like every industry we talk about is about to be transformed by robots.
And we've only just begun to explore the possibilities. Robotics is changing agriculture, construction, even entertainment.
Robots as farmers and builders and entertainers. It sounds like the future is going to be pretty wild. But it's important to remember that robots aren't some kind of magic solution, right?
Exactly. We can't forget that. Technology is a tool,
Yeah.
a powerful tool, but it's up to us how we use it. We have to make sure we're using robots to make things better for everyone, not just replace people.
I think that's a really important point. But overall, I'm feeling optimistic.
Me too. If we're thoughtful about it, if we use robots wisely, I think we can create a better future. For everyone.
That's a great way to put it. Well, that's a perfect lead-in to our next discussion. We can get into more specifics about how robots are going to be used in all these different industries.
Yeah, I'm looking forward to that.
Okay, so we've talked about those big trends that are going to be shaping the future of robotics.
Mm.
AI, soft robotics, and of course, all the ethical stuff that goes along with it.
It's a lot to consider, isn't it?
It is. But now I'm really curious to see, like, how's this all going to play out in different industries, like in the real world?
Yeah, it's one thing to talk about the technology in the abstract, but seeing how it's actually being applied,
Right.
that's where it gets really exciting.
So let's start with manufacturing, since that's where robots, kind of got their start.
Absolutely. And manufacturing's always been a big adopter of robotics. But it's changing fast.
In what way?
Well, remember those old industrial robots? Big, bulky, kind of dangerous. They had to be kept separate from human workers.
Yeah, like caged off for safety.
Exactly. But now it's all about cobots, collaborative robots.
robot?
Yeah. They're designed to work right alongside humans, help with tasks that are, repetitive or strenuous or need a lot of precision.
So it's not about replacing people. It's about, like, teamwork.
It is. Humans and robots working together, each one playing to their strengths.
Makes sense. But I'm sure some people are worried about their jobs.
Oh, for sure. And that's something we need to address head on. As automation increases, we need to invest in education and training. Make sure people have the skills for the new jobs that will be created.
Right. So it's not just about the technology. It's about preparing people for the future.
Exactly. But let's move on to healthcare now.
Okay.
We already touched on surgical robots.
Right.
But that's really just the tip of the iceberg. There are so many other ways robots are going to be used in healthcare.
Like what?
Well, think about nurses. They spend a lot of time on routine tasks, right?
Yeah.
Checking vital signs, giving medication, even moving patients around. Imagine robotic assistants that could handle all that.
Wow.
It would free up nurses to do what they do best. Provide care, connect with patients on a human level.
That sounds like a good thing for everyone.
It is. And robots can go beyond just helping with tasks. They can monitor patients constantly, collect data, and even alert doctors if something seems wrong.
Wow. So they could help prevent problems.
Exactly. And we're also seeing robots being used in rehab, helping people recover from injuries, and soft robots, they're opening up all sorts of new possibilities for prosthetics and assistive devices.
So it's not just about treating people after they're sick or injured. It's about helping them live better, healthier lives overall.
Exactly.
Okay, well, let's shift gears again. What about transportation?
Ah, yes. The self-driving car.
It seems like every time I turn around, there's a new story about self-driving cars. But are we really on the verge of a world where cars drive themselves?
We're closer than ever before. There are still some challenges, of course, but self-driving cars are being tested and deployed all over the world.
I have to admit, I'm a little nervous about the idea of sharing the road with a robot driver. I mean, what happens if something goes wrong?
That's a valid concern. And safety is absolutely the top priority.
Right.
But think about this. Human error is a huge factor in most accidents. Self-driving cars, they don't get tired, they don't get distracted, they don't make bad decisions.
Yeah, that's true. And I guess we already trust computers to fly airplanes.
Exactly. And self-driving cars have the potential to make our roads a lot safer. Plus, think about all the other benefits. Less traffic, less pollution. And it would make it possible for people who can't drive themselves to get around easily.
So it's not just about the technology, it's about the positive impact it could have.
Exactly. And that impact's going to be huge, not just for personal cars, but for trucking, deliveries, even city planning.
It's amazing.
It is.
It seems like every industry we talk about is about to be transformed by robots.
It's true. And we've really only scratched the surface. We could talk about robots in agriculture, construction, entertainment.
Wow. Robots as farmers and builders and entertainers. I can't even imagine what's next.
The possibilities are pretty much endless. But it's important to remember that robots aren't a magic solution for everything.
Right. Technology is a tool.
Exactly. It's up to us to use it wisely, to make sure that robots are helping us, not hurting us.
That's a really good point. But overall, I'm feeling pretty optimistic about the future of robotics.
Me too. If we're thoughtful about how we develop and use these technologies, I think we can create a better future for everyone. A future where humans and robots can work together and where technology helps us solve some of the big problems we're facing.
That's a great way to put it.
Yeah.
Well, I think that about wraps up our deep dive into the world of robots. It's been a fascinating journey, and I'm so glad we had this conversation.
Me too. Thanks for having me.
Of course. And everyone listening, thanks for joining us. Keep exploring, keep learning, and we'll see you next time.